For example, alcohols always have that medicinal smell that they do, that kind of, it's very pungent would be a good way to explain that. There's also things called aldehydes, ketones. I mean, there are tons of different functional groups. You are going to have to learn the 6 main ones. And for the first one, this could be better because there really should be 2 carbons here on either side of the carbon double bonded to the oxygen. That's called a ketone. There's also an ester where you've got a carbon double bonded to an oxygen, and then another carbon. That's called an ester. A carboxylic acid has a carbon double bonded to an oxygen, and then to another oxygen and a hydrogen. So even though it's similar to an ester, it's completely different in how it reacts and how it smells or tastes. An amine is a carbon bonded to a nitrogen. An alcohol, like I already discussed, is a carbon bonded to an oxygen and then a hydrogen. And this next set has you kind of look for the functional group that's within the molecule. So you have to start spotting them. And so here you see a carbon double bonded to an oxygen surrounded by 2 carbons. That's a ketone. In this one you see a carbon double bonded to an oxygen and then an oxygen and a carbon. That's an ester. This one has the oxygen and then the hydrogen at the end. That's a carboxylic acid. Here's the amine, the carbon bonded to a nitrogen. And this one has the alcohol, the carbon bonded to the oxygen and then the hydrogen. These are all called structural formulas. What you're seeing here, this whole thing is a structural formula. So it's a drawing or a diagram that a chemist used to show how the atoms are connected. It's a 2D picture. And it says number 3 on this page, which is showing the all the pictures of the functional groups. It's just telling you that it wants you to know that there are 5 structural formulas total. The molecular formula is just saying how many atoms there are within the structural formula. So, for example, C5H10O2. That is the molecular formula for letter C from number 3, which is the fill-in-the-blank notes. So going back to that one, you can see 1, 2, 3, 4, 5 carbons, 1, 2 oxygens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that is why it gets that molecular formula. A bond is represented as a line in those structural formulas. So a double bond is 2 lines, so how many lines would you need for a triple bond? 3. Question: can molecules that have the exact same formula smell differently? Yes, the same molecular formula, because there are things called isomers. So in the lab that we did, you smelled C4H8O2 twice. One of them smelled horrible, putrid, and the other one smelled sweet. That's because there can be a different arrangement of how the carbons and oxygens and hydrogens are bonded together. So what we're going to learn about next is how do you even draw these molecules? Like, there are patterns and there are special rules. So for example, looking at these pictures, you can tell already how many lines or bonds must carbons always have. Well, they always have 4 lines around them. 1, 2, 3, 4. No matter what carbon you pick out, it always has 4 bonds. How about nitrogens? There's only 1 here, but nitrogens always have 3. Hydrogens always have 1 bond, and oxygens always have 2. So what do you think the rule honk 1, 2, 3, 4 means? Well, it's just like it sounds. Hydrogen goes with the 1 because hydrogens can form 1 bond. Oxygen goes with the 2, etc., etc. So now you can use this rule to actually do some drawings of your own. Here's the rule that a lot of people forget. Always start by connecting the carbon atoms together. Then any other atoms that are not hydrogens. You can connect them to the ends of the carbon or somewhere in the middle. Finally, fill in with the hydrogen atoms last. Problem solve until you've got the correct number of bonds for each element. Sometimes you have to go back and double check and make sure that everything is following the rules. You might have to add a double bond or something like that to make everything work out. Tip: things that can form more bonds are more likely to show up in the middle of the structure. Alright, so then you had to draw each of these: CH4, CH4O, CH5N, and C4H10. And so for each of these, for the carbon, it's just 4 lines surrounding that carbon and a hydrogen on each of those. Here, you have to start with the carbon, connect it to the oxygen, and then there's 3 hydrogens around the carbon and 1 hydrogen off of the oxygen. For the CH5N, you start with your carbon and attach it to the nitrogen, and then there's 2 more hydrogens off of the nitrogen and 3 hydrogens off of the carbon. C4H10, there's a couple ways to do it. Here's 1, 2, 3, 4 carbons all in a line, and the other way is 1, 2, 3 carbons in a line and 1 coming off of that center carbon. A lot of people think they'll draw this in like a zigzag, or they'll draw it like straight up and down, and they think they've drawn it differently. But this is completely different because a bond was broken and moved down here. So you have to be really careful when you draw isomers. Again, what is an isomer? It's 2 molecules or more that have the exact same molecular formula, like C4H10, but they differ in how they're arranged. So they have different properties because of that. Look at, these guys have different shapes. Do you think they're going to interact with receptors in your nose or your mouth the same way? Definitely not. And that is it for right now.